Okay, next lesson. I know the last lesson was a bit tricky, but the good news is this next lesson is actually quite easy because it's the start of the chapter. Okay, and move. Move now. Get your sandwich? And you ate already?
Yeah.
Jeepers, that was quick. Oh, physics students. Physics students. Of course, I didn't say it, but don't forget there was a homework from the collisions as well. We finished the collision.
This is the math class, we don't discuss physics.
Use your best imagination. Pretend I'm the physics teacher for a moment.
You don't look like it.
I know, we're totally different, but pretend. And don't forget to do the physics homework as well. Okay, let's start then. Chair doesn't seem so great. No, I don't trust it.
Okay, take this chair.
Yes, it's just holding my bag right now.
You can put your bag.
He trusts that chair with his bag.
So I think it's okay for me. Right. Now, I think we're on to a new chapter, Starry. We're on to a new chapter. Yes, we are. Indices and logs. Logarithms. And we're going to look at this today, indices. Another word for indices, powers or exponents. So that's things like this, x with a power. Okay, if you didn't know these words, please write these words down. Come on, Omar. Here, you can sit beside me. No? Alright. Okay, did you write that down? Have you got that? Yep. So, first thing we want to have a look at is some rules of indices. No. Can I scroll down? Yep. Okay. So, first rule. When you have two numbers that are the same but only have different powers, then the result is the number with the powers added together. We'll do the proof. It's very simple. xn, xm. This is x how many times? N times. And this is x m times. So, of course, obviously, the answer has to be x n plus m times. So it's not even a proof, it's obvious that the answer is x n plus m. Okay, so that's our first rule. Write that one down. We have a few more to do. You have that one? Yeah. Yeah, second one now. So, in the second one, might not surprise... Oh, sorry. Do you have this? Yeah. Second one, xn over xm, that's going to be xn minus m. And I should really say for this, x is not 0, because otherwise that's silly. And definitely here, we won't consider x being 0. So the proof, xn over xm, we have n on the top, and we have m on the bottom. And what you can do is you can cancel each time. So you're left with n minus m on the top. So in other words, that's x n minus m. Again, it's not really a proof, it's obvious. Okay, so that's the second rule. If you can write this one down, please. This is rule 2. And this one was rule 1. Okay. You wrote this down? Yes. Are you writing these down? I don't know. Everything? Including the proof?
Well, the proof makes it more complicated than the other stuff.
But remember, I'm trying to develop you as a person, you know.
Well, developing.
Yeah, I'm trying to, you know, grow you as a person, make you a better man. Yeah. Okay.
You just give me 5 seconds.
You see, he cares. Yeah.
I'll proof 1, just the formula.
Here, 5 seconds.
5 seconds.
I gave you an extra second because I like you. Right. Number 2. Can I go on to number 3 now? Yes? Okay. So number 3, with the proof. xn power m, double powers. This will be xnm. Okay. So again, the proof, not too fancy. xnm, that's xn, how many times? M times. Because that's what power means. And we know from the first rule, rule 1, we can add the powers together. How many times do we add the powers together? M times. So this would be m times n. Okay. So write that down with the proof. Great.
M times or M times?
Yeah, that's right. Yeah. Mm-hmm. Continue. Yes. Okay. These are pretty obvious. Now on to ones less obvious, I suppose you could say. If you have something like x minus n, and that's 1 over xn, and again, the same here, we won't consider 0 for the moment. So likewise here, we won't consider 0. The proof, pretty easy. X minus n equals 1 over xn. If I bring the xn up to the left, oh wait, no, you haven't done that one yet. No, we won't prove it that way. We'll prove it. X minus n equals x 0 minus n, which equals x 0 over xn. That's from rule Which rule did I use here? To go from here to here? That's from rule 2. Okay. Now, we don't really know what x0 is, do we? We haven't said that yet. But I'm sure we said it before in the binomial lesson.
Anything power 0, 1?
It's 1. Yeah. But we haven't really said that yet. So what I'll do is I'll change this into x
We can
1
improve it.
minus 1 over xn. I know, bear with me. x1 minus 1 is x1 over x1 over xn. That's 1 over xn, because they cancel. So x is definitely not 0.
Every number has 0 equals 1.
Yes, every number power 0 equals 1. Almost. Not every number.
Which number is that?
You'll find out shortly. Continue? Well, let me just scooch up a bit. The next one I'm going to do is x power 1 over n equals... Does anyone know this one? I'm sure someone knows this one. The what? What?
Square root n.
Square root n?
No, x and something.
Nth root
Yeah, that's
of
what
x.
I mean.
Nailed it. Right. Again, the proof. Not so difficult. Can I scroll down?
Yeah.
So, x1 over n equals the nth root of x. The proof is very easy. You just put power n on both sides. This will be x n over n, and this will be x, because that's what the nth root means. You know, if you have the square root, and you square, what do you get? X. If you have the cube root, but you cube, you get x as well. So you get x power 1 equals x, so x equals x, obviously. Yeah. Some people write this in some books as, you know, xp over q equals q root xp. If that's what you've seen in high school, that's fine as well. Yeah.
Could you repeat the part where you square the whole thing by n?
I put power n on both sides,
To make...
and these multiply. This is rule 3.
Oh, sorry. They're so different.
Okay?
Yeah.
Yep. Finally, rule 6. Can I scroll down? Rule 6. It's not really a rule, just some facts. So, for example, 1 to any power is equal to 1, except 0. And then x to power 0, what does that equal? 1, except x is not 0. And 0 power 0 equals...
Non-defined. 0.
Right, no, you're giving me many answers. Commit to one answer after you think about it for 5 seconds at least. 5 seconds at least.
1.
It's not
0.
Not have what? Not have 1?
Not there. Undefined.
Yeah, what's the...
Undefined.
Undefined.
Yeah. No value. Undefined. Did you type in 0 power 0 on the calculator? Did you?
No.
You know it, yeah. I think if you type 0, 0 on the calculator, what does it say? says error, yeah.
Syntax or not?
Math error. Yeah.
What's this?
Syntax just means you type an error. You made a mistake with the brackets, maybe.
Math error is that you're writing wrong math.
Yeah. Math is wrong, yes. Okay, do you have those 6 rules written down? Yeah. Let's have a look at some examples. They're not very difficult for today.
Steve,
Yeah.
what is n over m?
N over M.
X n over m divided by n.
X N over M like this.
Yeah.
Oh yeah, I briefly said that here. If you want, you can write that as x 1 over m power n, and this is the mth root of x, and this is power m. Or you can also write it, there's actually a couple of ways you can write it. You can write it like this as well. Wait, I'm thinking. X power n on the inside and 1 over m on the outside. So that's mth root of x power n. So you can write, Andrew, you can write it like this or like this.
The one I said was nice too.
What one did you say?
X power n over x power n.
This?
Yeah.
It's nice and it's wrong.
It's wrong. N minus n.
N minus m.
Yes. Yeah.
I was just testing you.
Did I pass?
Yeah.
Good to know. Alright, can I do some examples now? Let's have a look at some examples. They're very, very easy for the first lesson here. Right, so the first example, x power 6 over x power 4. Now I would like you to tell me which rule. So which rule is this? Yeah. It's x6 minus 4, which is x squared. Yeah. Okay, write this one down. This is our first example. Okay, next one. Now, don't use your calculator. That's not what they want in the exam here. And before anyone asks me later, the answer is yes. So someone in 5 minutes will say, but can't I do it this way? The answer is yes. Okay? So if you are thinking in 3 minutes, can't I do it this way? The answer will be yes. Unless your way is stupid, but it's probably not. There are many ways to do this. I'm going to show you one way. If you have another way to do it, yes. And one more time, the way you're thinking of, yes, you can do it. So do not ask me in 5 minutes, but couldn't I have done this? The answer will be yes. Okay? Do you understand? So don't ask me in 5 minutes, can't I do it this way? I'm just showing you one way to do it. I hope I've been clear. Now watch. So what I'll do first, I think I can get rid of this 16, because the square root of 16 is 4. Four times 4 is 16. And then the next thing I'm going to do is cancel here. 16 goes into 16 and 32. So this is square root 1 over 2, fifth root of 32. I will change that into fifth root of 2, 4, 8, 16, 32, 2 power 5. That would be square root 1 over 2, 2 power 5, 1/5. that would be square root 1 over 2 times 2 power 5 over 5, which is 2 power 1, which is square root 1 over 4, which is square root 4 minus 1, which is square root 2 minus 2, which is 2 minus 2, a half, which is 2 minus 1. Teacher, can't I do it? Yes, you can do it another way, if that's what you're thinking. I just did it this way because that's what I felt like doing. Please write this one down. If you have a quicker way of doing it, a different way of doing it, that's fine. Yes, being lost is okay. That's okay. That's natural feeling. There's lots of steps here. There was lots of rules here. So I'll write down all the rules. So the first one was no rule. Well, not really a rule. Then from here to here, no rule. Here to here, no rule. But here to here, what I did was I changed 32 into 2 power 5, going to here. And then from here to here, I used rule 5, wasn't it?
Yeah.
Rule 5. And then from here to here, I used rule 3. Then from here to here, it wasn't really a rule. Then what did I use from here to here? That was rule 4, wasn't it? And then from here to here, it wasn't really a rule. I just changed 4 into 2 squared. Then from here to here, that was rule 5. And then here to here, the last step was rule, which one? 3. You don't have to do as much as this, but in the exam they want to see something. Okay? Got that? Continue? Okay? Not yet. Wait, am I just waiting for one person? Oh no, sorry, one person's not enough. No. I will leave a man behind.
Yeah.
One is not enough, sorry. Okay, next one. I'll let you try this one, then I'll do it. This one here is the same, except it's no numbers. But it's the same idea. Square root x fifth root x minus 5 over x minus 5. I think that's fifth root as well. X 5. Okay. Simplify this. Shouldn't take you too long.
done.
I'm reading my mail now, and it says like, as long as there's no university thing you have to go to on Friday, which I don't for the physics students. Isn't there some pharmacy thing in the morning or something?
Yeah, it's
Is there a pharmacy thing you have to go to on Friday morning or something?
yeah, it's over here only.
Yeah, is that Friday?
Yes.
Yeah, but that's only for you and not
Yeah.
for you. Yeah, so Connell says it's okay as long as there's nothing you have to go to, like the pharmacy thing.
No, in the morning there's a lecture from the pharmacy, I think from Cork University.
In the morning.
Yeah.
Yeah, so we can do the physics test on Friday then.
Great. Now, do you know the answer for this? That was my question.
Ah. I will in 1 minute when I do it. Alright. Let's have a look at this. Yes?
But Friday I go to the class.
Oh, yes.
She is one. You can leave one man.
No. No. I said not one man behind.
Yeah, one woman.
True, it is. I never said I wasn't sexist. I never said that. You're going to Cork on Friday. No, wait. No. I think you have to go to Cork, don't you? Are you going with the other Vietnamese students? You're all going to Cork on Friday.
But she's the only one that takes physics and is going to the.
But I'm the physics student.
Yeah, that's right.
Yeah, that's what I'm saying. But
And you're going to Cork on Friday.
no, is it going to Cork on this Friday?
You're going.
Wednesday.
Shh, but now be quiet, please. I'm so hungry. I can't concentrate straight. You are going to Cork on Wednesday. On Friday, you are still in the college. You just have a lecture to go to in the morning. You're going. Do you know what day you're going to Cork?
No,
It looks like it's Wednesday.
I follow them.
If Fuang is not going to Cork on Friday, we can have the physics exam on Friday. Please talk to Fuang after class and let me know. It depends completely on you. No pressure. Alright, let's have a look at this one. First thing I'll do, I'll change this into x minus 5 power 1/5. And here x minus 5, x5 power 1/5. This will be x power 1 over x power 5. And this will be x power, they multiply, that's rule 4, no 3 isn't it, minus 1, and this one here is x power 1. Is that okay? On the top they add, and on the bottom they add. So on the top I have this, and on the bottom I have this. So that will be 1, and this will be x minus 4. This will be x4 and a half here. The half because of the square root, and I'm just bringing this back up. I'm using the rule 4 backwards. If you didn't like that, you can do it like this as well. You can say this is 1 over x minus 4 power a half, which is 1/2 over x minus 4/2, which will be 1 over x minus 2, which is x2. This is rule 4, isn't it? Yeah, rule 4, but just backwards. So x squared is the answer?
No.
Yeah.
Sorry, Fuang, I hear a lot of yeses, and my answer at the back says x squared, so I think it's x
I
squared.
used to this and
Did you? And did you get the right answer?
no.
So I think this way didn't work.
But I think my way is right.
You think so? What answer did you get?
It's,
You know this word. What is it?
Power.
our
Yes?
minus 2.
No. That's no. I'll check what you did later, okay? Trust me and the rest of the class. Okay. Right, another example. One plus x cubed x squared. I want you to write these as powers. So this will be Pascal's triangle. 1 plus 3x plus 3x squared plus x cubed over x squared. This is 1 over x squared plus 3x over x squared plus 3x squared over x squared plus x cubed over x squared. This is x minus 2 plus 3x power
-1.
plus 3x power
1. Whoops.
x power
1.
1. That's what I wanted here. Okay, write this example down. Please write it down. No thinking required, just writing. Got this? Yeah? Okay. Next, can I go down? Yep. Okay. In maths, there are some important constants. For example, this one is important in maths. You learned this one in school,
Why?
middle school. Yeah, it's an important one. There is another constant as important as pi, and this constant is called E. Yeah. It's roughly 2.71828 roughly. It's built in on your calculator, so you don't have to remember it anyways. But it's an important constant in maths, and it's very important in calculus, which we'll do later. But just for now, I just want you to practice using this on the calculator. So for example, calculate something like e power 3. So if you take out your calculators, try and find the E button on it. I'll show you where it is on mine in a moment. Did you find it?
Yeah.
So what, how do you read it?
What do you mean?
E.
Oh, how would you say it?
Yes.
Just E cubed.
You just call it E.
Expecting something more?
Yes, I thought it was kind of a first letter or something.
Oh, exponential constant. How's that for you? I just made that up right now.
Oh, really?
Yeah. Right. So on this calculator,
Alpha.
no. Shift alpha.
I swear it is.
No, Shift E.
That's the other one.
That's
the other
There's another one.
There's another one.
The times 10 to the 4 factor.
Yeah, I got the same.
Alpha exponential. You get it.
Where the heck is alpha exponential?
Besides the answer.
Right, the alpha.
Besides the answer.
And then
Yeah, beside that.
left to the answer.
Yeah.
And you cube.
Power. Yeah.
The same button as pi, but alpha. That's it.
Yeah.
Okay, right, okay. You have two ways to do it on your calculator. 20.09. Yep. I don't understand why it's on the calculator twice. I don't. Wait, no, I do.
One is for the power.
One is with a power, one is without a power.
So the way I did it was quicker because
Yeah.
I have Shift E 3 equals, that's 4 buttons. Alpha E
Shift. No, press shift. Press shift. No,
1.
alpha A and then shift.
Hang
Then
on,
it's the
brother.
same 4 buttons.
Hang on. Watch.
Who can play this game?
Count. 1, 2, 3, 4. Okay, now watch. 1, 2, 3, 4, 5. Yeah. My way is 20% quicker. Yes. Okay. Did you write that one down?
Yeah.
Yes? Right. Listen. The last thing to show you, and then I'll let you try some questions, is the graph of these function. Faisal, please, I'm so tired and I'm so hungry. I haven't got the energy for this right now. Right, so let me just put a box in here. So we're going to look at the different graphs we can get with A, E, B, X. So the shape depends on what you have for the A and what you have for the B. So the first graph we'll do is if the A is a positive and the B is a positive. Then the next graph here, the A is a positive, we'll do A is negative, B is positive, and here A is positive, B is negative, A is negative, B is negative. Okay, please write these down. These are the 4 possibilities you have here. No, it's just I'm showing you the different shapes you got. Okay, the first one, if A and B are both positive, the graph will look like this. Please note, it does not touch the x-axis and it will never be negative. And this point is A. If A is negative and B is positive, the graph will look like this. Please note, it will never touch the x-axis and it's always negative. If the A is positive but the B is negative, it will look like this. Again, never touches the axis, is always positive. And if A is negative and B is negative, again, never touches the axis and is always negative, and it'll look like this. So these are the 4 different graphs you get here. Asymptote, correct.
Direction of quotient.
What do you mean?
The arrow points.
Omar, you have a question? Okay. You know you can ask me. Don't be shy. Yeah? Okay. So you can start your homework now, and you'll probably get it finished now because there's 10 minutes left. Can I scroll down? Right, so homework then. Homework A, B, C in each question. Okay, you can start it now, and like I said, try to get it finished now, and then you don't have a homework for this. Okay. Can I close this? Okay, but can I close this? Right.
There is no answer for question number 6.
Yeah, because they're a drawing. So I didn't have space, I don't think, or I was too tired to make the graph. We'll go with I didn't have space, since that makes me seem better. Okay.